Okay, so I pulled this one off your Chapter 3 test review. So you will see this one again when you're prepping for your Chapter 3 test. This one says in a recent study of 102 senior citizens, since it's only 102, it's not every senior citizen. This is a sample. Okay, and with the sample size of 102. The mean number of hours that they slept, now this is again, it's a sample. So the mean, this is X bar because it's a sample, is 9.6. Assume the population standard deviation, there's the keywords right there. That's sigma, the population standard deviation is 1.1. Now, the sample size is greater than 30, so we don't care whether or not the population is normal or not. We have a big enough sample size, so our sample is normal. It says find the 96th confidence interval. And I picked this one because I don't believe 96 is a number that's on here. So we're going to have to calculate our critical value. 96 is not on there, which is why I wanted to do it. So find the 96% confidence interval for the population mean. This is what they want me to predict. Remember, a confidence interval is wanting me to predict something about the population, and it usually is the mean. Round your answers. There's the rounding rule to 2 decimal places. Also give the margin of error. So we have to calculate the margin of error and write the values you use to perform your calculations with technology. So this right here, especially if you're using StatCrunch, you've got those written down, but I'll demonstrate what I mean for you in just a second. Let's go ahead and draw our picture. And it doesn't matter whether this one is either a Z or the X. Let's go ahead and do it Z since we're going to have to calculate this. We can't just look it up. So that's our Z. So this will be 0. And we want this to be 0.96. Okay, that's the area that we want to find, 0.96. So we want to find this because this will be the easiest to do the area to the left. So we're going to try to find this number right here. This is our critical value. And it'll be the negative one, and then this will be the positive one. Okay, and so that's what we're looking for, right? Well, we'll have to do that to find a margin of error, but let's go ahead and find that. So what do? We do 1 minus 0.96 divided by 2. So 1 minus 0.96, that's 0.04. Divide that by 2, we get 0.02. So you can go look it up on a table. You can use a calculator. I will show you how to use the calculator in another video. Or you can look it up on here. You could probably do it on StatCrunch too. I'll do it on StatCrunch. Let's look it up on the table first, and then I'll do it on StatCrunch. So we're looking for what am I looking for? 0.02. 0.02. We're looking for an area of 0.02. 0.02. So it's going to be pretty close in between there. This one's 3 decimal places away from being 0.02, and this one's only 2. So it's a little bit closer to 0.5. You'll see what I'm looking at. Let me grab, let's see, let's do this little purple one. There's 0.02. I'm really close to 0.02. Right here and right here. 0.02 is somewhere right between there. So I'm looking at negative 2.0, and it's going to be somewhere between 5 and 6. So we could just use, and I would tell you to go to where the one that's closest. It's closest to this one right here. So we would say Z is it's 2 negative 2.05. Now, when we look it up on StatCrunch in just a second, it's going to be, there's going to be another decimal behind it. So let's go look it up on StatCrunch real quick. How would we use StatCrunch to do this? No, my dogs are killing me. Killing me. We would go to Stat and we would go to calculations and we would go to a normal. And let's make this bigger. Uh-oh, I didn't make it bigger. I made it smaller. What did I do with it? Let's do this. There it is. I'm trying to make it bigger. All right, and we need a Z value when the area is 0.02. And we're going to calculate, and there it is, negative 2.053. And if we'd want to round that to 0.054. So you can see right here that there's where this is this area right here. This area right here is 0.02. This area right here, what was it, 96. And this area, it's going to be over here. This area over here is going to be also 0.02. And you add all of those up and you get 1. So that's why we're looking up that one right there. So the critical value, the Z-score, is negative 2.054. So it was a little bit between. So negative 2.054. And I would probably 2.05 would have been fine. And this is 2.054. The reason I wanted to do 3 decimal places is because it said to round my answers to 2 decimal places, and these are numbers that I'm going to use to calculate the confidence interval. And so since I'm using it to calculate, I'd like to use 1 more decimal place than they want me to round. Because if I just use 2 decimal places, then I'm going to end up with a possible round-off error. So, okay, so there's that. And you can calculate your margin of error by using the formula. Your margin of error, remember, is your Z-score, 2.054, times your population standard deviation divided by the square root of your sample size. Okay, that's going to be your margin of error. And then for your x-axis, your mean is 9.6, and we're looking for this number and this number, and we're going to find it by adding our margin of error, and then we're going to find it by subtracting our margin of error. So this distance right here that we're finding, that's the margin of error. Okay, so do this calculation, and I'm going to pull up 2.05. Oops. 2.054. Dadgum. 54 times fraction bar 1.1 over the square root of 102. And press enter, and it shows us our margin of error to be 0.224. And again, I'm going to use 3 decimal places because I'm using this number right here to get my final answer. And so I'm going to want to round it to 3 decimal places so that I don't get a round off error. So 0.224. So my margin of error is 0.224. So I add 0.224 to 9.6 and I subtract 0.224 from 0.96 and I get my confidence interval. So my 96% confidence interval is, and again, remember, I'm going to do this in just a second on StatCrunch, and then I'll make a separate video on how you can do it on the calculator. So 9.6 gives me 9.82, and this is where I am going to do 2 decimal places because it's my final answer, 9.82, and I'm going to do 9.6 minus that number right there, and that's going to give me 9.38. So 9.82. So this is 9.82. And then the other one is 9.38. So this is 9.38. And that should be the answer. So 9.38 and 9.82. So we're 96% confidence that the mean of the population will be somewhere between those two values. Let's run over to StatCrunch. We can close this down now, and we're going to go to Stat. We're going to go to Z-Stats, one sample with summary, and our sample mean, I don't remember what it was. Our sample mean is 9.6. So that's 9.6. Our standard deviation, wasn't that 1.1? Our sample size, I believe, was 102. We're doing a confidence interval for 96%. I don't want to put it in the table. Let's see where else it comes up because that table keeps getting longer. This will show me a picture of it. Okay, so there it is. There's my lower limit and my upper limit. Is that not what we wrote down? My lower limit and my upper limit. 9.38, 9.38, and 9.82, and 9.82. So it's the exact same thing that we got on StatCrunch. And if you go over here, you can see there's the 9.6 is the mean. There's the lower limit, upper limit. So it just shows you where it is, where the endpoints are. Okay, so there's that one. And I think that answered all of the questions. Right, the value. So I would say that I used StatCrunch. And what I did on StatCrunch is I did stat. And then what did I do after that? I did stat, and then I did Z-Stats, and I did one sample. So I want you to show me that you did stat, and then you did Z-Stat, and then you did one sample. And then you did a summary. So that's the table. I mean, that's the order that you chose. So that lets me know that you really did it, stat. And then you put in, it asks for the mean, it asks for the standard deviation, and then it asks for your sample size. So all of those things that you typed in. So you would say your mean was 9.6, your standard deviation was 1.1, your sample size was 102, and your confidence interval was 0.96. So this is where you're just making a list of all the things If you use your calculator, I will show you what you would want to write down on your calculator. But this is your technology. This is your answer right here. 96% answer right here. Oh, and if they wanted it in inequality notation, it would be 9.38 is less than x is less than. Actually, they might put mu right here because it's saying that our mean of our population is somewhere between 9.38 and 9.82. That's actually what we should have been doing, not x. But because that's what it asked for, the population mean. So we're saying that our mean is somewhere between those two. All right, so that's everything that I would expect you to show me. You've given me everything here. And again, you can work backwards from this information, just like we did. You can do the confidence interval and then subtract those from each other to get your margin of error. You don't have to calculate it, but that's great that you show me if you calculated it. Okay. All right, I'm going to stop this video, and then I've got one more example to do, which is this one right here, and then I'll make a calculator video. So 2 more videos.